everybody. MoNaCo here.
And Milks.
We are working on our 6th video, something like that, yeah. In our packs, page 2021. We're basically paraphrasing and reiterating the properties of ionic and covalent compounds.
Right, kind of concise. Right next to each other.
Quick bullets. Yeah. So ionic compounds, the first class that we study. There's a great picture of the diagram of ionic bonding there.
And the little one are covalent, ionic. The thing I was noticing the most, part of the reason why we're going to get a difference in properties, is look what happens to our ions when they get. We've got a big one and a small one.
Bulk properties.
Right, and when they hook up, they form like puzzle pieces. So when they get in there together, that even the size of them puts them really snug in there. Plus they got this whole magnet thing going on, so they really stick.
And 3 dimensions.
Right.
Like there is no quote unquote molecule of sodium chloride because it's a sodium ion and a chlorine ion stuck together. That's the smallest unit.
Just keep going like Legos until you're out of it.
Yeah, and so if you're talking about a crystal of salt, which is like a cube, well, it's related to the reason and way that the ions are packed in together there.
So let's do the
properties. Properties, boom, hit it up. Positive and negative ions lead to great attraction between themselves, of course, leading to the following things. MP and BP. Geez, what MP and BP be?
Melting point and boiling point.
So you mean the fact that these ions are stuck to each other real hard like means that they boil and melt at very high temperatures.
Right. I mean, to the point where you and I cannot melt table salt at home or in the lab.
Can't do it.
We don't have anything hot enough.
Hundreds, if not thousands of degrees.
Well, it's just, I think it's just under 1,000 degrees Fahrenheit. It's like 900 something.
I don't know exactly.
It's like 770 Celsius.
It's hot.
Yeah.
3D crystal lattice. This is that picture in the top right corner. All ionic compounds make one of these. This one's for sodium chloride. It is a specific shape. It's very cubic. Other ionic compounds, different ions, different shape to the crystal, where you get into what you studied in mineralogy in earth science, because those are all ionic compounds. They are hard or brittle solids, meaning they are good at making rocks, hard or brittle solids. And lastly, they conduct electricity or allow water to conduct electricity when they're in solution or they have been melted down. Because it's about electricity and solid, liquid, gas are all about mobility of the particles.
Definition of electricity is flow of electrons.
Right, from one anode to the second, the cathode. So
if I have a bunch of little negative ions there in solution,
they allow the water to conduct the electricity.
Right.
They don't create electricity in water. They allow it to conduct electricity because you're pumping electrons in on one side of this system and then they're moving through, jumping from ion to ion, if you will, to the other side, allowing it to conduct.
But it makes for a good test to find out if something's ionic or not, right?
For sure. Right. Dissolve a little in water, see if the water conducts electricity.
So let's go over covalence now, or code word molecular. If you ever hear MoNaCo or I, or that big bad test talk about something that's molecular, that's code for covalent, because ionics don't form molecules.
Nope.
Okay, so because there's no plus and minus ions, this leads to a less attraction, leading to lower melting points and boiling points.
Yep.
We could make a real mess with some sugar and melt it down, and it'll turn all black real fast, start smoking.
And we're talking relatively low.
Right. I mean, compared.
It takes, you can melt sugar. To you and I as human beings, it would be very hot to touch. But into these elements and compounds as they are in nature, that 150, 200 degrees ain't nothing.
Compared to the 1,000 it takes for salt.
Exactly.
Right. So there is no crystals. They exist mostly as gases or liquids. Okay.
There's a couple solids, graphite, carbon, phosphorus, and sulfur. But
most of them are, and then they're very soft. So if I hit them with a hammer, they smush
or shatter.
Yeah,
smush or shatter.
Yeah.
They're not conductive.
And they're not conductive. So it doesn't matter what I do with them, they're not going to conduct electricity, whether I put them in water, melt them down, nothing. Because there's no ions floating around, especially those negative ions that act like electrons.
And I'll just say that this hardness and softness is a relative thing too.
Sure.
Because there are some covalent compounds out there that are really stinking hard.
Well, yeah, but you look at a sugar cube and it looks kind of hard, right?
It's kind of soft though. You can switch it.
It's going to mush.
That's not a good test to see if something's
No,
ionic or
no,
not.
conductive is great.
And
boiling
melting
point.
point, melting point. That's
Those
it.
are the two
We're never
big
going to tell you, okay, crush this and see which one's ionic.
No.
It's you
No.
can't.
We're
You're
gonna
not
say
able
melted.
to
We're
detect
gonna say
melted
conduct electricity.
or conducted electricity.
Okay.
Now this next class,
Oh, we got a new table.
yeah, properties of a polyatomic ionic compounds. These are the same as ionic compounds. Okay, and a polyatomic ion is just a group of atoms that are covalently bonded that have a charge forming an ion
Because they lost or gained electrons.
as a group.
As a group.
As a group.
And now as a group, I'm not going to be able to split them up.
Nope.
The amount of energy it takes to split them up is not worth it.
Not
And you'll find that we like to keep them in parentheses a lot of times.
protect them with shields.
Yeah.
So this ion group covalent or ionically bonds to a metal. So even though the group itself is covalently bonded together, like nitrogen to oxygen,
Right, making nitrate.
right, NO3 here, in this case, 3 oxygens, 1 nitrogen, they're covalently bonded together, the nonmetals are. They are ionically bonded to the sodium.
Right.
So both kinds of bonding are present when you see a polyatomic ion.
Hint.
That is always out there.
And that
Which
question
one of the following compounds contains both ionic and covalent bonds?
Right, the trick then is to look for the
Polyatomic ion.
find it.
That's it.
In table E. So when in doubt, check E out.
Mhm.
You'll find that you won't find an N, a capital N, capital O on the reference table together.
Nope.
So now you got to go to table E and check it out.
See what else we got here.
So let's do some more characteristics quick.
Quick rundown. Ionic bonding, transfer of electrons make ions, opposite ions attract, makes a strong bond. Metal loses electrons to the nonmetal for many reasons. I like to say it's because the effective nuclear charge for metals is low, but the electronegativity and ionization energy is also low as a result, so they lose electrons.
Right, metals are losers.
Metals are losers.
Right, so covalent bonds, we share electrons specifically now between two nonmetals. So there's a major contrast there. We're sharing and not transferring, and then they form a weaker bond as a result.
These are still relatively strong, let's say, but not compared to those of the ionic compounds.
Right. Right. So
Now this last one, metallic bonding, they're free valence electrons. So when you get a bunch of metals in bulk property together, like a billion aluminum atoms sitting next to each other, and you put you like try and pump some electricity in on one side and let it go out the other side, these electrons, start to bathe around the atoms, creating this sea or ocean of free valence electrons. There's so much of them, if you will, that the positively charged metal nuclei are just like, yo, electrons, have as many as you want, man.
right, 'cause I'm going to get some more here in a second.
They're bathed in a sea of electrons. There's electricity's traveling through the metal because they can play hopscotch from one atom to the next, to the next, to the next, never spending too much time.
So quick review, malleable means I can pound it flat into a sheet, right? And ductile means I can draw into a wire, which is good because we have copper wires lighting all our lights and running all of our smart boards and computers.
Yeah, and that's indirectly the property of the fact that the valence electrons are free.
Sure. And then, of course, it's conductive. So as a solid, I don't need to dissolve this stuff. I don't need to melt it.
Nope.
It's the solid.
You pump electrons in one side, they just play hopscotch through all the atoms all the way to the other side where they're coming out. They don't create electricity.
No.
They let electricity pass through it.
Right. And it is a difference. So we'll do that. So, hey, again, if an ionic and covalent bond is present, look for a polyatomic ion. It's on table E here on the right.
It lists all the ones that you're responsible to know. And even then, you just should know to go look. Don't memorize them all.
No,
just
look.
notice if you see
guessing.
a chunk of atoms at the end of a compound that look like they kind of go together with parentheses around them or whatever.
Yeah.
Go check out table E. I mean, it says polyatomic ions right there.
And if you look on the table real quick, it's almost all nonmetals. I see permanganate that's got manganese in it.
Yeah, rare. Dichromate got chromium in it.
Yeah, but most of them are all nonmetals, so they're covalently bonded.
Yep.
And then that ion that they form ionically bonds to the metal. So that's where both kind of bonds are present. So there you go.
So this was a quick rundown for y'all. Hope it was a good lesson. Transfer of electrons for ionic, high melting point, boiling point. Know those properties. Know them. We're going to do a lab on it, but you still got to know them.
You got to know it. And they're key words, guys. Covalent, key word, sharing of electrons to nonmetals.
They're all testable words, too.
Very testable. That's what I mean. Right. Low boiling point, soft, non-crystalline, non-conductive.
Remember, when in doubt, check table E out.
That's right.
We also say check table S out. So when in doubt, check your reference tables out.
Seriously, guys, no guessing in chemistry.
Don't.
It's very, very
With
detail-oriented
the resources
stuff.
that we have,
Use
just
it.
find it, match it, use it, do it.
Sweet. Another
Thanks
one's
for
done.
listening.
Hey.